What is TypeScript? TypeScript is simply a strongly typed programming language that builds on JavaScript. This type of error was so common before, so TypeScript came first to solve this issue. For example, here we have console.log house.room number, and then we get this error: property room number does not exist on type house. So we are trying to access a property which does not exist. So TypeScript actually came to save us a whole lot of stress as a JavaScript developer. It is a superset of JavaScript. So TypeScript adds advanced features like interfaces, like decorators, like classes, like access modifiers, just as we have in other languages like C#, Python, Java, and many more. It uses the latest feature of JavaScript. TypeScript is compiled to JavaScript. So this means that TypeScript can run anywhere JavaScript runs. For instance, in browsers, Node.js, and native mobile apps. What do we need in order to learn TypeScript? First, we need Node.js installed. So you can come to nodejs.org and install the latest stable version. Next, we need to install TypeScript. So you can come to the TypeScript documentation, and now let's open our terminal. And in the documentation, we have all instructions on how to install TypeScript. So we can install this via the npm, and we can simply install TypeScript globally on our computer. So here we can simply enter npm install. You can use I globally, so we use the G flag, and then TypeScript. If you're on Mac, remember to add sudo here. But if you're on Windows, you don't have any issues. And now you hit enter. So you enter your password, and this is going to install TypeScript. Now let's confirm if we have it installed or not. And to do that, you simply type tsc, then you use the flag version. And now we can see that TypeScript is properly installed. Great. So the next thing we need is a code editor. I will recommend using Visual Studio Code because Visual Studio Code itself is written with TypeScript. All right, now we are ready to start learning TypeScript. Let's see how we can actually run our TypeScript code. First, we can compile TypeScript to JavaScript, then run it in a Node environment or the browser. We can also compile TypeScript directly using a package called tsnode. So if you have tsnode installed globally, which you can actually install the same way we installed TypeScript. And with tsnode, we can directly run our TypeScript code without the first step of first compiling to JavaScript. Also, we can bundle with a building tool like Webpack, Pasu, then run in browser. This third option is actually what is used in modern frameworks like Angular or library like React. For now, let's see how we can use the first option. Here on my desktop, I'm going to create a folder which I'm simply going to call TS. Now let's open this in our code editor. If you're on Windows, you can simply right click on this and you will see an option to open with your Visual Studio Code. If you're on Mac, simply drag and drop this into your Visual Studio Code. And now let's create a file. Let's call this example.ts. And the first rule of TypeScript is that any valid JavaScript code is also a valid TypeScript code. So for instance, let's write const to username is equal to great. And let's actually console.log username and save this file. Now, let's use the first option, which is compiling this code, this TS code, to JavaScript, then using Node to actually run the compiled file. So we do that by opening our terminal, and here on our terminal, we simply use tsc And then the name of the file is example.ts. Just run this. And now this creates a new file with the JS extension. So you see, this is the initial code we wrote. And now this is what we have. This is the compiled code. So the next thing we are going to do is to type node and then example.js. So the first thing is tsc example.ts. We are using node example.js. And now we get great, which is what we have here. So next, let's use the second option, which is the TS node. Remember, I said if you have TS node installed globally, you can also run your code directly without the first step, compiling to JavaScript, then running with Node. So here I can also do example.ts, and you see this actually gave us the correct result. Great. But for now, since we are just learning, we are going to be using the first option, because having these files, we will be able to compare and deeply understand how the TypeScript compiler works. Anyways, for now, I don't want to bother you with this, so we are going to undo this very soon. So if you want to get around with this error, you can simply change this const to var. And for now, let's continue learning TypeScript. We will see why we are having that error whenever we use const or let very soon. You see, when you use const or let, you have the same thing. For now, let's keep using var. So let's start with the most important feature of TypeScript, which is the type system. Now, if you put your mouse on this, you actually see that username is a string. Now, let's try something. Let's take username and let's equate this to 7. Now we have this error that type number is not assignable to type string. And this is because the type here is actually a string. TypeScript will never allow us to do this. Now let's also declare another variable. Let's say room number is equal to 20. And now let's take room number and equal to. Immediately you do this, you get an error that type of string is not assignable to type of number. So we cannot also assign a string to a number. We also have the Boolean type. So we have is logged in. Let this be false. And now if you try taking is logged in, equate it to, let's say 30. This also is going to give us an error, because type of number is not assignable to the type Boolean. So these are the basic types. Now, if you look at all these types, they are actually inferred. So for instance, is logged in is inferred because we never specify that this is a Boolean. But this is inferred because it is taken from its value. So TypeScript is wise enough to know that the assignment here, that is the first assignment, this actually is a Boolean. And so the type here is inferred. And also for the room number, the type is also inferred as number, because here this is number. If you change this to a string and put your mouse on this, you see that this now is a string because the type is actually taken from the value. So let's change this back to a number. Now, another way we can actually define our type is by explicitly specifying the type. So here we can also do something like this, TypeScript, then you put colon and you specify your type. And here is of type Boolean. And this also works. But for these basic types, the type annotation here are not actually useful. So we don't need to do this for these basic types. Now, let's look at another important type, which is array. We can actually define an array. Let's say name array. And for an array, we specify the type by simply writing array. And now we can specify what exactly we want to have inside the array. For instance, we can say string. And for now, let this be equal to an empty array. Now, if you try doing name array.push, so for now, let's push great and save. This is going to work. For instance, if we console.log name array, we are going to have great inside that array. So first, let's compile. Now, if we try to compile, remember you can access the previous command here by simply pressing the arrow. You can use the arrow up or arrow down. So first, let's use our TSC and then let's compile our example.ts. Great. So next, we can now use node. We use node and compile our example.js. Okay, and now you see the array and we have great. And also you see what the TypeScript compiler does. So this is our array. This is the array we defined, and now it pushed great inside the array, and also we console.log name array. As we proceed with this course, we are going to be looking at this file and we are going to really understand how the compiler actually works. Now, let's try doing something like name array.push. Let's push 2 inside this. And now we have this error. Argument of type number is not assignable to parameter of type string. So because we defined this array as a string array, this array can never accept any other thing apart from strings. So here, if you try pushing, let's say you want to push boolean, you see we are going to have the same error. Argument of type boolean is not assignable to parameter of type string. So you see we can only add strings inside this array. Now, another way we can write this, so let's comment this out. We copy this code, and for now, let's comment it out and paste it. So instead of writing array of string, we can simply write string and then you specify arrays. So this here is the same as this. Now, what happens in the case that you actually want this array to accept anything? So instead of writing string array, you can change this to any. Now you see the error is gone. We can now push anything into this array. So we need to copy this console.log and put it here. Okay. Now if you compile this, you see that the array now contains great, 2, and true. So it contains first this, and this. But using any is actually not recommended. So this should be the very last option. But I just want to show you that you can actually get around with this. Now let's change this back to string, to our string array. Another way we can use any is actually to do something like, let's say name array.push. Now let's push is logged in. Remember that is logged in is a boolean. So we can't push a boolean into this array because it's an array of string. But if I really want to get around with this, I can also use any in this form. And now you see I don't have this error. But remember, using any is actually not recommended. For now, let's remove all this. The next thing we are going to do is to actually look at something. So let's just write a simple function. And let's say this function should get a user. And the function is going to accept a username. And it should simply return the username. Now, if you look at this now, place your cursor on this. You see that this username implicitly has an any type. And this is because we did not specify the type for this username. One thing we can do now is actually to call this function. If you call this function and pass in 5, you will actually not get any error. And this is because we do not specify exactly what we want this function to accept. So here now, if we come here and specify string, so now let's specify string here. And here now we have this error. So this actually is an example of what we call the user defined type. So this actually is an example of what we call the user defined type. Now, if you place your mouse on this, you actually see that the TypeScript compiler is very smart. So wherever we call this function, we must pass a string. So here now, if you pass a string of, let's say, great, you see that the error is gone. Now, let's look at a more useful example. So let's define another function and let this function get user details. So this function is going to accept user info. And now let's look at what we call an interface. So to define an interface in TypeScript, we simply write interface and let's call this interface user. And you simply write it this way. So here, let's write the username, and the username should be of type string. Let's specify the card number. The card number should be of type number, and save this. Now here in our function, we can now say that this function should actually take the type user, okay? And what we are going to do now is to simply return. So we return the user info dot username as a card with number, and then here let's enter the card number. So it's going to be user info dot card number, and let's save this file. Now on this function, we actually see that the TypeScript compiler is also very smart because it already knows that the return value for this function is actually a string. So now if you specify that this function should return a string and you try returning 60, this is not going to work because now we have an error that the type number is not assignable to type string. If you remove this string here, you are not going to get an error because now you are returning a number, and the TypeScript compiler will be so smart to now tell you that this function returns a number. So let's go back to what we have before. Now we are returning a string. So even when we do not specify this, the compiler will pick it that yes, we are returning a string. Now let's look at something very important. So what we do is now to console.log, we call this function getDetails. And you see now we are going to be forced to specify this type. So wherever you use this function, you must actually pass the type. So you must pass an object of type of this interface. That is, here we must pass an object containing a username and card number. Now, if you put your mouse here on this arrow, you see that the type, you see here we specified empty object. So the type of this is missing the following property type: username and card number. So here we must indicate username, and now we can say Bob. And remember, the username must be string. If you write number, for instance 80, you are going to get another error. Type number is not assignable to type string, and that is because here the username is a string. So here it must be string. So here let's say Bob, and next we need to enter the card number, and the card number should be a number 40, and now we don't have any error. Now look at this function. Let's compile this code actually and see something very nice. So tsc and our file name, then node example.js. Bob has a card number with number 40. Let's look at the code here. Okay, if you look at this code, this is the function we just defined. There is something you need to pay attention to. In this file, there is nothing like an interface. So here we have this interface, but in this file, we don't have the interface, and also the type is not specified here. So this here is a pure JavaScript code. That is very important to know. Okay, now apart from the interface, another thing we can do is to actually use the type. So here we can write type, and let's say user title. And for the user title, we can do something like the user should be a Mr. or, so we can use this or, and we can specify Mrs. So for this type now, you can actually specify either this or this. So here now, let's say title should be of type user title. Okay, so now this title must be either Mr. or Mrs. And now here we need to add the title. So here we can say title, and we can specify, you see the options. if you put any other thing here, you are going to have a problem, because now this is not assignable to type of user title. So user title is either a Mr. or Mrs. Here now we can simply specify Mr. And when you do this, you see that the error is gone. You see how good this is, because this saves a whole lot of stress. It's very easy for us to know exactly what we need to pass into this function. So we are beginning to see the beauty of TypeScript. Just a recap of what we did. We defined this interface and we called it a user. And this user should have username, which must be string, card number, which must be number, and title. And the title should be of type user title. And to define a type in TypeScript, you simply use this type keyword, and then you write the name and specify whatsoever you want. Here now, we can simply usually use Mr. And if you do this and try writing Mrs. here, you are going to get an error because this is just a Mr. So in order for Mrs. to work, you can also use this or. So we can specify that this is Mrs. We can also use another one. You can keep adding to this. You can also write Miss. You can do a whole lot of things. Here also, we can pass Miss without getting any error. So what we did here is simply what we call the user-defined types. Now, let's pay attention to what we did here. We see that even when we do not need the title, here our function returns the string, and in here, actually, we do not need this title. So there is also a way out in this. So in TypeScript, we can also pass some properties, which is going to be optional. And we do this by simply adding question mark here. So now, even when we do not pass this title, we can remove this title and we do not have any error again. Look at what happens where you remove the question mark. And now you see we have error because we need to add the title here. So the optional property actually helps us to get around with this. Now let's actually add more optional properties. So here we can say is auth. So we can check if the user is authenticated. This is going to be a Boolean. And now you see we have this error because this is actually required. To make it optional, we must put this question mark. And now the error is gone. Now let's look at one thing here. Look at this function. It is returning a string. Now let's do something here. So we are going to check if user info.isAuth. So if this is actually true, we want to return the string. So we only want to return the user detail if the user is actually authenticated. Yeah, because if the user is authenticated, then we want to access the username and the card number. Else, we simply want to return undefined. So here we are simply checking if the user is authenticated, we are going to return this. Otherwise, we are going to return undefined. Now, in this case, this function return type is going to be of type string or of type undefined. We also have the undefined. If you look at this function now, you see that TypeScript compiler is so wise. Now we know that this function will return either a string or undefined. We can also specify that here. So here we can say string, and if we specify only string, we have a problem because now we are returning undefined, and this function is meant to return only string. So you see the beauty of this or, we can now use or undefined, and now everything is okay. So let's actually run this code and know what happens. So here now, this is optional. We are not passing it. And in this case, we are supposed to get undefined. So let's check and see what happens. Okay. Now let's compile. So it's going to be tsc example.ts. And now let's run this. And now you see we get undefined. Great. Now let's now add this option. So is auth, and let this be true. Let's save this and run this again. So let's compile, and now we should get Bob as a card number with 40. I hope you understand this, guys. Now, another thing we can do here in this function, we can actually add what we call an optional parameter. So we can do is admin, and this should be Boolean. So you see now we are getting this error because this function now, this get user detail, must take two parameters. So now we have to pass the user, we have to pass an object of type user, and also we must pass a Boolean. So here now, if you put comma here and maybe write true or false here, you see the error is gone. Now, I want this to be an optional parameter. We simply put the question mark, and now even when I remove this true, I don't have any error. Now we see how we can work with optional properties and also optional parameters. You are going to see something like this very well in TypeScript code base. I need to call your attention into something. Remember, when we compiled this code, this interface is not included in this JS file. So we simply say that the interface does not exist during runtime. So it does not contain any implementation code. And this is a drawback. Now, what if we are getting an object from, let's say, a REST API, and we want to undo it? We have to do some checks to make sure that that object is actually of type user. How do we do this? Therefore, in this case, we are going to use a function, and in TypeScript, this function is called guard. So what we need to do is to accept that object from the API, and we are going to check if that object, that is, if the user info coming from the external source, if it is of this type. And then we are going to do something. Let's simply see how we can write such function. Let's define a function, and let's call this is user. And this function is going to take in user info. So let's call it incoming user info. So this user info is coming from an external source, so we do not know the type. So here we can simply, in this case, we can simply use any because it is coming from maybe an API or any external source, so we do not know the type. But the goal of this function is to check that this particular user info is of type user. Okay, so now here we know that this is user should actually return a Boolean, so we need to specify that here. The return type should be Boolean. And now we get this error because now we must return a Boolean. So we simply want to check if in incoming user info and add number in incoming user info, here we are going to return true. Else, we simply return false. So what are we doing here? Here we are dynamically checking. So this is a way to dynamically check if a particular property exists in an object. So this function is going to accept an object coming from an external source, which we do not know the type. The type is any. And then we want to check if this property and this property exist in that object. So remember that we are checking for these two properties because the remaining properties here are optional. So if this and this, so these two must exist. In this case, we return true, else we return false. Now let's actually write another function. So this function is going to get user detail if user. So now we have to check if. So here we can call this function if is user, and we need to pass the incoming user info. So this function also is going to accept the incoming user info. So we check is user, and remember that this is user function is accepting the incoming user info. Let's specify the type here. It is actually any. Here, let's console.log. So our first function, which is this function that gets the user details. So let's console.log get user details, and now we are going to pass the incoming user info. Else, let's simply console.log incoming user is not recognized. Now let's look at what we are doing here, because now we are having a function calling other functions. So what we are simply doing here, this function is going to accept a user coming from an external source of which we do not know the type. And then we are going to pass the incoming user info, that is that incoming user, into our isUser, into this guard. And the function of this guard is actually to confirm. So we want to check if the incoming user info is of the type user. And remember, the incoming user is only of the type user if it has these two important properties, because the remaining two are optional. So in this case, we want to get the user details. Otherwise, the incoming user is actually not recognized. So now let's call this function. But there is another thing we need to check here. If you look at this function, you see that Typescript compiler is very, very smart. This function is not returning anything. That is why here you see void. Why? Because the function is not returning anything. If you look at this, here you see Boolean, because the function is either returning true or false. And if you look at this, the function is returning a string or an undefined. So here we can also specify void. This function returns nothing. And we can see that we are only console.logging what we want. So now let's call this function. So get user if user, get user detail if user. So let's pass incoming user. Let's pass here, let's say username Joy. Okay. Now you see we do not get any error because this incoming user here is of type any. So here you can specify whatsoever you want. But now let's run this code and see what happens. So back. So now you see that incoming user is not recognized. You see the guard is actually working. And now let's say our username is a number 9. Now let's compile this. You see incoming user is not recognized. We could do this because this incoming user info here is just anything. But now let's see what happens if we specify the correct incoming user info. So here, let's say the username is Joy and that the card number. So let's enter the card number. Card number should be, let's say 50, and save this. Let's compile this. Okay. And now node example.js. Now we get undefined. This is because in the get user details. So let's go to get user details. We said that if user.isAuth, then we want to return this. Otherwise, we return undefined. Now, when we call this, we do not specify isAuth. Now, look at what happens when we now specify isAuth. And here, let's say true. In this case, we are going to get our required string. Now, let's compile this again. So, node example.js. Now, you see, Joy has a card number with 50. So you see now how guard work in TypeScript. Let's look at what we call the compiler options. The compiler option is simply the way the compiler will undo our project. And remember I mentioned that the TypeScript compiler is really sophisticated. That is, it has a very high level of complexity. So to actually undo these compiler options, we need to create a file which is called the tsconfig.json file. We can actually create this file by generating it here from our terminal. We simply type, so here simply type tsc and then you use the init flag, and this is simply going to generate the tsconfig.json file, which is what we have here. Now if you look at these options, the most important ones are the ones uncommented, while most of the options are actually commented. The best way to understand this is actually to use it in your project. So what we are going to do now is to actually remove everything we have here, and we are going to write this step by step. So the first thing we need to pass is what we call the compiler options. So here, let's add the compiler options. Okay. And now let's specify what we call the root directory. The root directory is simply the directory that is going to hold our files. That is our TypeScript files. So here, let's write src. Great. So the next thing we need to add, since we already have a root directory, let's also add the out there. The out directory is the directory that is going to hold the generated JavaScript files. Okay, so here we simply specify out dir, and we are going to call this dist. This is the real world standard. So in industries, this is specified this way. Now, when we save this file, we are going to get an error. And this is because the TS compiler actually need the src and the dist folder. So let's call this src. And here we move our TS file and put it inside the src. Okay. Next, let's create another folder, and we are going to call this dist. Now, let's move the JS file and put it inside the dist. Great. Now you see that the error is gone. Let's go back here and actually compile this code again. First, we can delete this JS file. Now, let's recompile our example.ts. So when we compile this example.ts, our JavaScript file should now be located inside the dist. Now the dist is empty. So let's clear this. Now, to compile this, we only need to type tsc. We do not need to specify the file name because the compiler is going to undo that by itself. So here, let's enter. And now you see that the example.js file is now located inside the dist folder. Perfect. Let's continue with our tsconfig file. The next thing we are going to look at is actually the lib option. That is the library lib. So now, if we do not specify anything here, we are going to have many issues, because now the TS compiler is not going to understand most of the things in our code. For instance, you see that console.log is not recognized. You also see that the array methods. So let's go back now. Inside this ts.config, for the compiler to understand this console.log, here we now need to specify what we call the DOM. Now let's save this file and now go back to our TypeScript file. You see that the console.log, everything looks good now. But let's go back to this array method. So now we have to specify another thing. So here let's add the ES6. Okay. And now let's save this file. You see that the error is gone. I hope you are beginning to understand what this compiler option is and how the compiler actually works. The next thing we are going to do now is to add another option, which is called the target. So let's add the target. And by default, we see that the compiler will resolve your code in ECMAScript version 3. So by default, even when I do not specify anything here, so if I try typing target and click on this, you see it's going to specify version 3 for me. Now we are getting this error because the ES3 is deprecated and we stop functioning in TypeScript 5.5. But for now, let's ignore this error. And now let's go to our TypeScript file to actually understand what this does. Because now our output, that is the JS code, is going to be of this form. Now let's actually do something here. For now, look at the way this file is. Okay. Now let's actually write an async function. And let's just say get name. The function is not going to take any parameter. And here, let's simply return name. Okay. And here, let's simply return an empty string. Okay. Now, let's actually compile this code and see what happens. Let's compile the code. So all we need to do is to enter TSC. And now we get this error telling us that the ECMAScript 3 is actually deprecated. But let's go to the generated code. You see what we have here. So the compiler generated all this stuff just to understand this async function. Now let's go back and remove ES3. So instead of ES3, let's use 20 and let's save this file. Now let's clear the command line and let's run this again. You see, now we don't have the error, but let's see something very, very interesting. Now you see this same file is very neat again. And now see how our async function is simply defined, because here we specified ECMAScript 2020. So now let's continue learning TypeScript, and we are going to be looking at this file as we progress. Let's actually look at classes. Classes was also introduced in JavaScript in the ECMAScript 2015, but TypeScript take classes to a new level. So this is the part that anyone coming from Java or C# background will actually begin to feel very familiar. So to start with classes, let's actually add another file. So in our src folder, let's simply add another file, and I'm going to call this house.ts. Okay, and to define a class in TypeScript, we simply use the keyword class, and here we use house. So it's always a convention to have the same name of the file as the name of the class. So here I'm going to use out. This is the simplest way of defining a class. But I have a question. Why are we actually using this? Why do we need a class? If you go back to our TS file, example.ts file, you see that here our code is actually becoming very difficult to understand. So class actually makes it very easy for us to organize our code and actually scaling our logic. So a class can have a constructor, instance variables, and methods. So let's start with instance variables. Here, let's simply add house name, and we are going to say this is of type string. Also, let's add house number, and this is going to be of type number. Now, let's add rooms, and this is going to be of type number. Okay. So the next thing we are going to add here is a constructor. We can either leave our constructor this way or pass instance variable. So here we can say house name should be of type string, and also the rooms should be of type number. And in here we can now say this dot house name. So we are accessing this particular house name. This dot house name is equal to the house name here. Okay, is equal to house name. This dot house number is equal to this particular one. You see now that, do you see that this now is highlighted, because that is what we are specifying. If you click on this, you see you have this. If you click on this, you see that you have this. I hope you are understanding this keyword. We are going to talk about this very soon. Okay, so house number, we are going to equate it to this house number. And immediately we do that, you are going to see that this is going to be highlighted. Okay, house number. And now you see, great. Okay, and then this dot rooms is equal to rooms. Perfect. Another thing we can also add here is what we call a method. A method is basically a function. So a function inside a class is called a method. So here, let's just say, and since it's a method, we don't have to specify a function here. No, we don't have to do this. In fact, doing that even gives us an error, because this is inside a class. Okay, so you simply write the name, and in here, all we just want to do is to simply console.log this dot house number. Or let's make it more fun. Let's say the house, and the house should be, let's use the house name. So this dot house name, and we are accessing this here. So this keyword actually this keyword in here is actually referring to this house here. Okay, we are going to talk about this and how this object works very soon. Okay, so we say the house name as number. So let's indicate the house number, and that will be this dot house number. Now, the next thing we need to do is actually to initiate this class, to create an instance of the class. We simply do that by saying, let's say first house is equal to new. We use the new keyword and then we write the name of the class. So let's say the house name is beauty home. The house number is 80 and the rooms inside this house is 200. Okay, now let's actually call the method inside this class, and we can simply call the method by using the instance of the class, which is this first name. So you see that the first name is of type house actually. Okay, and now we can access any of the instance variables, but for now we are interested in the method. And let's save this and run the file. Remember that when we call this, remember that this actually here is calling this function, and this function is going to console.log this here. Okay, now let's run this. Let's run this by using TS node. Just let's do this and see. We want to see the results. Okay, and that is going to be src/house.ts. And now we have the beauty home as number 80. Next, let's actually compile this. So let's compile this using TSC and let's see the output. Okay, great. Now in our dist folder, we now have two files, the example.js and house.js. Remember, we have two files here. Let's look at this. And now you see that the class is actually neatly defined. Why do you think this is so? Let's go back to the tsconfig.json. You see that here we specified ES 2020 as the target. Now let's change this. Let's change this back to ES3. And now let's go back. Of course, it is deprecated and that's why we're having that error. But now let's actually compile this again, TSC. But instead we are seeing this. You see this. Now we have this function. Remember in JavaScript, when we talk about a class, we always say something like a synthetic sugar. Now you're beginning to see this. Now let's go back and change this back to ES. Let's use ES 2020 or ES 2022. So we can use 2020. And once you compile this again, so we can clear the command line TSC and go back to the house.js. Now we have our class. So you are beginning to understand what you can actually do with these options and how you can instruct the compiler to actually do what you want. All right. I hope this makes sense. Let's now look at what we call the access modifiers. So we talked about the instance variables and also methods. We can actually add access modifiers like public, private to these instance variables or methods. So by default, since we do not specify any access modifiers, all the properties we have here are actually public. And that is why here we can actually access, for instance, for first name dot any of these instance variables or method. We can explicitly specify this. Now let's look at what happens when we make this house number private. Okay, now when we make this private, let's also make these rooms private. Now let's do the same thing again. So first house dot. Now you see that we can only access this method because it is public, and also the house name which we made public. It is a good practice to always set all this to private. So it is a good practice to always set all these properties to private. and only make those methods that we want to access outside public. So here now for this get house number, we can simply make this public. And now when we do first name dot, we only have access to house number. You see, we only have access to this get house number. So these are what we call the access modifiers. Before we look at another access modifier, let's actually look at something. So now that we know how to use the public, the private, we can actually refactor our code. So what we can do now is to remove everything we have here in our class. Now we are getting this error. So here now we need to specify, here now we need to add the access modifier. So using the access modifier here, we can use it here. We can also put public here. Now you see that the error is gone. But for now, I think it is more easy to understand when we leave it this way. So as we move on, you can refactor your code and write it the way you want. But I just want you to know that that is now possible. Okay. Now, before we leave this session, another thing I want to show you is that now the question is there a way of accessing a property that is a private property outside this class? Is there a way of doing that? So let's say house name or house const house is equal to, so what I'm going to do is to say first house, and I'm going to put this in a bracket. So I'm going to access first house as any, and now I can access the house name, you see. So what I did here is to actually, this here is the instance of the class house. So I'm accessing, so now I am using this. Remember we used this when we talked about the array type. Now I am writing first house as any, then I want to access this house name. In fact, we can see this in the console. So let's see console.log house. Okay, now let's use the TS node and let's run this. You see that we have beauty home, which is what we specified here. So by doing this, we can actually access this private property even outside the class. Now let's look at another access modifier, which is actually the protected. So for these rooms, let's remove private. Instead, let's write protected. And this actually will lead us to what we call inheritance. So now let's define another class. So let's write class. So let's call this subhouse. And to actually inherit a class, so for this class to inherit the house class, we only need to use the extends keywords. So subhouse extends house. And now we need to write our constructor. And for any class that actually extends another class, inside the constructor, it is a must to add the super. So we must call the super here. Okay. And now inside our constructor, we can actually pass the same thing we have here for now. So here, let's pass everything we have here. And inside our super, we can now specify house name, house number, and now rooms. Okay. So in here now, let's actually define a method. So let's write a method to get the house name. Now inside this method, let's try looking at something. So let's say console.log this dot. Now, if you look at this dot now, we only have access to get house name, which is actually this get house name, because the this here is referring to this sub house. Okay, of course this method is inside this class. We also have access to the get house number method. Remember, because this is because the sub house extends the house class. So because the get house, so the get house number here, you see this here is actually public. It is not private, and so we can access it. Now, the only thing we now have access to, the only property we have access to is the rooms. And this is because the rooms here, here it is protected. So remember that the private, we have no access to the house name nor the house number, because these are what? They are private. Let's change this private to public. Okay, and let's save this file. Now let's come here and do this again. So this dot, you see, now we have access to house number. Why? Because house number is now public, but we do not have access to the house name. So look at this, we do not have access to the house name. Okay, so let's change this back to private. Okay, and for now let's remove this. So with the private keyword, we can only access this property inside the class. Now we cannot access it outside the class. Using protected, we can access the property inside the class and in any other class that extends that class. And then using public means we can access it anywhere. I hope you understand this. So class can also be abstract. So we can actually make this class an abstract one. So we can say abstract, and now this is going to give us an error. Cannot create instance of an abstract class, because this means that the whole point of the class, the whole point of this class now is to be extended. So you see that with this, with extending it here is not a problem, but creating an instance of an abstract class is not allowed. Okay, now let's actually comment this out for now. Let's comment it out. An abstract class can also have an abstract method. So here now we can actually add abstract, and let's define a method that gets all details. Okay, and this method is going to return void. So we can basically define an abstract method like this. But the point now is that when an abstract class has an abstract method, that abstract method must be implemented in any class that extends that class. So now we have an error because we need to implement the abstract method. So we can easily come here now and we simply write get all details. We even have access to it already. So get all details, and with this we no longer have that error. So this is how class works. We have our class, we inherited the class, we changed the class to an abstract class, we added abstract methods, and once a class is abstract, you cannot create an instance of that class. You can only extend that class. And of course, we can now create the instance of the class extending that class. So now let's uncomment this. Okay, let's uncomment this. And what we are going to do now, instead of new house, let's use the sub house. Okay, so sub house. And now you see that the error is gone. And let's run this code and see what we have. So first, let's clear our terminal. And now let's run the code with TS node. And you see everything was correctly. And I hope this concept is clear. Please just pause and repeat this on your own. Go through this again. Also, this abstract class is not used that much, but it is also very good to understand how this important feature works. As we progress in this course, I think it is a good time for us to actually go back to interfaces. So remember in this example, .ts file, we actually used an interface here to define how an object should look like. Now, we can also use interface to do some other things. For instance, we can use the interface actually to define how a class should behave. So for now, let's remove this abstract. Let's actually remove this. Okay, for this, I'm going to comment it out. And now let's change this to house. Here, we don't need this abstract. Let's simply implement this here. Okay, so now this house class actually has two methods. Remember, when you did not indicate the modifier here, it's simply a public. To make our code cleaner, let's simply specify public. Okay, now we can actually use interface to define the behavior of this class. Now let's do something. And what we can do now is to define an interface here. So we say interface. By convention, you simply use I here. So this should be I house. And now here we are going to specify get house. So let's copy this get house number and let's put it here. And this is going to return void. So this is going to be a method and it is going to return void. Let's add the second one, which is get details. And our get all details is also a method and it is going to return void. Okay. Now this class, let's now do something. So now this class, we simply write implement I house. So what we are simply saying is that, so now we are simply saying that this house implements I house. This here is very powerful because now when we miss any of this method, for instance, removing this method, then we are going to get an error because the class house incorrectly implements the interface I house. Property get all details is missing in type house, but required in type I house. Do you see that using this for your classes is actually very good? Because this will help you catch a lot of bugs on time. So here now we simply need to implement get all details. Now let's see another thing that this can actually do for us. So I'm going to change this back to public. Okay, let's change this also to public. Now let's go back here. And if you look at this now, so when we access get house dot, you see we have access to everything. We have access to all the properties and also the methods, since everything is now public. Now look at what happens if we now specify the type here to be type I house. Okay, now when you try accessing this, you only have access to the get all details and get house number. So we see now that this interface actually defines how this class should behave. Wherever we create an instance of that class, we can only access these two methods and every other thing is safe, even when we do not define them as private. So this is a very important use of interfaces. Now let's look at another cool feature of TypeScript, which is the generics. Generics are very important in TypeScript. So for instance, define a function. Let's call this function getValues. This function is going to take a generic type and accept some parameters. So let's call this args. And this parameter is going to be a generic type. So we specify the T here. And here we return arg. Okay, so now let's call this function and simply let's pass an object. Okay, place your mouse on this function. You see that this function actually takes in now this object where a is a number. Now let's write const and let's call this val and let this be equal to, copy this now and put here and place your mouse on val. You see that val now have this type of an object with a being a number. Now let's actually explore generics more. So in here, this generic, in here, this T, remember this T can actually be anything. So this can be anything. You can specify anything here. So CB, and this is going to work. But in general, we normally put T here. Okay. So we use T. You see, this can actually extend an object and this provides more flexibility and this is very useful. Now, let's actually look at interfaces with generics. And now let's define an interface and let's call this room. And this is going to have a generic type. And let's specify the room name. This should be string. And let's say the room number should be of type T. Okay, next, let's actually define a variable. Let's call this Bob room. And Bob room should be of type room. Okay, and this should be of type room of string. So this should be equal to, now since Bob room is of type this room, we need to pass in the room name and room number. So if you look at this arrow, these two here are needed. So let's pass the room name, and for this, let's call it Mr. Bob room. Okay, and now let's add the room number, and this is going to be 21TY. And you see, this works. Look at what happens when we try putting 7 here. This is not going to work because now we specify that this here. So when we call this room with the generic type here, we specify that this T should be a string. So what happened now is that wherever inside this Bob room, inside this object now, we need to pass a string here. So this type here must be passed. If you put a string, then there is no problem. Now, if you put a number, that means you have to change this from a string. You need to change this into a number. So you see, this is how generics work. So now I can also have another const, and let's call it hotel room, and this should be of type room. And this room is going to take a generic type. So inside this now, we now want to pass a string array. Okay, and this now should be equal to, first, let's specify the room name. So we can call this my room. You can call it anything. Okay, next, let's specify the room number. So we can't write any other thing here. We are going to have a problem. We can't write a string. This is going to be a problem. So the room number must actually be an array, and this now must be an array of strings. So here we can now specify whatsoever we want. If you put a number here, you are going to get an error because the array here, we specify this as an array of string. So if you want to use number, you have to indicate that. And also we can do something more. We can also use this or an array of string. Okay, so now we can either pass an array of number or pass an array of string without getting any error. Now, another thing we can also do, this can actually take any generic type you can think of. So this can also be just a string or just a boolean. So here we can specify boolean, and instead of an array, we can simply write true, okay, without any error. Now let's go deeper into these generics. If you've worked with Angular, you see that generics are also used more with observables. So let's simply write a class and let's call this observable. And this is going to take a generic type, and it is going to extend, so it is going to extend this room interface, okay? And remember that this room also expects another generics. So here we are going to put, let's simply put string, and now we need to close this. So here we are defining this, here we defined this class. This class takes in a generics, and the generics extends this particular interface here, okay? So the T here is actually a string in our case. We can use boolean, we can use a number, it's not a problem. You can use anything here. All right. So what we are going to do now is to actually simply add a method here. So let's write a subscribe method. So let's write a subscribe method, and this subscribe method is going to take in, so this subscribe method takes in, let's say, user information, and this user information actually is a generic type, okay? So in this subscribe method, all we want to do is to console.log user info. So user information dot. Now look at what happens. Now we have access to room name and room number. Why do you think we directly have access to room name and room number? This is because this type here, this generics, this T actually extends this room. So if we add any other thing here, for instance, if we add, let's say, test, and this should be of type string. And of course, here now we need to pass in test. And for now, let's just use an empty string. Here we need to pass in test. So test, here let's simply write an empty string. Now look at what happens here. You see, now we also have access to test. Do you see the beauty of generics? And man, we can do a whole lot of stuff with this. So simply let's access the room number. Now you see what is going to happen now. What we are going to do now is to instantiate this observable by using the new keyword. Let's call this observable. And remember that this observable takes the generic type T. So here now we are going to pass Bob room. So let's simply write type of Bob room. Okay. And now let's call this, and let's call the subscribe method. And now we call the subscribe. Remember that this subscribe is the method, and it takes in user information of generic type. So here, the T here, we said it is of type Bob room. So let's simply pass Bob room here. And let's save this. Let's compile this code. Now, if everything works as expected, we are supposed to get this value here, 9. Because Bob room here, the room number is 9. So let's try this and see what happens. And you see, as expected, it is 9. I hope you understand this. Please, you can pause this video and go through this. Even if you are new to TypeScript or you're already a developer, going through this is really, really important. Now, let's recap what we did here. So first, we defined an interface. And the interface itself takes a generic type. Inside the interface, we specify the room name to be string. The room number should be any type. So that means this room number could be anything. It could be an array, boolean, whatsoever. It is generic. And then we specify text to be string. Now we created a const. We created a variable, Bob room, and we assigned and we defined that this Bob room is of type room. But this T should be number. That means that the room number here, in the case of this Bob room, is of type number. Okay. So now we did another thing. This and this is the same thing. So we just created different variables. Now we define a class. And this class takes the generic type that extends this particular interface. So that means that this class automatically have access to room name, room number, and text. Remember how inheritance works. So this is also inheritance in the case of interfaces. So now this extends the room, and the room, remember that this room could take any generic type. So in this case, we are passing a number. Okay. So we define the subscribe function that takes in the user information, which is of this T. So whenever we call this observable, any type we specify is going to be the type for this T. So what we now did is to console.log user information.room name. Now here, we now instantiated this observable, and we said that the T, so this should be type of Bob room. Do you understand this? And remember, it is a class. And then we accessed this subscribe method here. So this is the same thing as, so we can actually say const first observable is equal to this. And now we can now call first observable dot subscribe. This will give us the same result. So if we run this code, we are going to get the same result. All right. this might not be too simple to grab once, please just pause the video and go through this. You can also check the documentation and look at how generics was, but most times you are not going to be implementing these generics yourself. You are only going to be using it. Now let's simply look at promises in TypeScript. So inside this house class, let's actually add a method here, and I'm going to call this a private method. So private get all rooms. Now let's assume that we are actually making an API call here. So we are getting the rooms from a REST API. So to do that, first we need to change this method to actually async. So here, let's simply return a string room. Okay. Now, if you look at this method now, you see that this method actually has a return type of promise, and it is promise of type string. So here now we can simply specify this miss, and this is of type string. Now, if you try putting a number here, let's say 7, this is going to give you an error because this actually is an async method, and async method returns a promise. And in this case, the type we specified is a string. All right. So for now, let's simply return rooms. Now, this is a private method. That means we want to access this method only within this class. So here, let's simply define a variable and let's call this hotel rooms. So let this be equal to, we are going to call the get all rooms. So get all rooms. Remember that this now should hold the value rooms. This should hold the value rooms. So what we are going to do is to console.log. So we console.log hotel rooms. But there is a problem now, and actually this is a common mistake. Remember that this get all rooms is actually an async method. It returns a promise. So any other method that calls this must actually be an async in order to await this promise here. So here now we need to add a sync here. Okay. And now this is no longer going to be just void because every async method returns a promise. It might be a promise of string, promise of any type. So here, since we are not returning anything, it's going to be a promise now of type void. Okay, now you see the error is gone. But now we need to await this, because if this is truly coming from an API, we actually need to await this here. So if any other method should call gets all details, that method also must be an async method. I hope you understand how this works. Okay, now let's actually run this and see what we have. So here we created an instance of house. So let's see what first house. So let's see what first house, but get all details is going to give us. Okay, let's run this code. And now you see rooms. You see the rooms. And this is actually coming from the async method, which is this. All right, I hope you see how this works. So I just want you to actually understand this type, because this is just a shallow touch of promises in TypeScript, but I just want you to feel how this works. Let's look at the street mode in TypeScript. So you can go to the TypeScript documentation, and here in the documentation, you can actually see the street. And here you can see some examples of these street modes, like no implicit any, no implicit this, always strict, and many more. Let's see this in code. So now let's go to our tsconfig file, and here let's simply specify no implicit any, and let's set this to true. Remember to put a comma here. Okay, now let's go to, for instance, let's go to our example.ts, or let's go to the house.ts. And inside this class, let's add another property and let's call this public house details. And now we get this error. Let's look at what the error is. Member house details implicitly has an any type, and we are getting this error just because of this here. So if you set this to false, let's set this to false and save the file. Now back to our house.ts file, you see that the error is gone. But here you can see that this actually has implicit, and so back here, let's set this back to true because this is actually a good practice. So let's go back here and now let's fix this error by simply saying that the property details should actually be of type string. And now you see that the error is gone. Let's actually look at another option here, which is what we call the strict null check. And let's set this to true. And here, let's quickly create an object and let's call it. In here, let's simply specify the name, the first friend to be Bob, and then the room number should be 8. Now, let's specify another friend, which room number is room 1, and the name of this friend is Grace. Okay, let's actually define an available friend. So let's say available friend, and let this be equal to, let's set this to grade. And now let's say the real friend is equal to friends to friend.find. We're going to find the friend which name is actually equal to the available friend's name. So this friend is going to take each friend, and we want to check that friend.name is the same thing as the available friend. And now let's console.log real friend dot, let's say .name, and we see that this raises an error because we've not made any check to actually know that the real friend.name exists. Now if we go to our ts config file and change this to false and save this file, now let's go back here. You see that this error is gone. And in practice, again, this here is very, very important. Next thing we are going to add here is what we call the strict property initialization. So let's add that strict property initialization. Okay, and for now, let's set this to true. Okay, now we already have an error even in our class. Why? Because this house details is not initialized. Remember that for these three, actually initialize them inside this constructor. So if you remove this from the constructor, you see an error. Property house number has no initializer. You see, and it is, so let's read it. Property house name has no initializer and is not definitely assigned in the constructor. You see how powerful this is. So let's undo this and leave this here. So for us to get away with this, we need to either initialize this to empty string or to any initial string we want, or either do the same as we did to all other properties. So if you set this to false, let's set this to false. Okay, and now come back to this and remove this. This is not going to give us any issue, but it is a very good practice to always set these strict modes to true. And finally, the last one we are going to look at, now we have this error. So let's initialize this as an empty string. The last one we are going to look at is what we call the strict. So this strict is going to do every other strict mode check, because we also have some other strict mode check that we are not looking at. So in practice, it is a very good practice to always set your strict to true. It is always better to set the strict this strict to true at the beginning of your project and undo everything once. But if you just complete all your projects before setting this strict mode to true, then you have a lot of things to fix, as you see, as we have here and as we've seen in this particular file. So I hope this is clear. Now let's look at what we call modules in TypeScript. Modules are a way to organize our code into smaller more manageable pieces. So for instance, if I need here in this out.ts, we have this iHouse interface. Now, assuming that we created another folder, so let's call this pages. And now inside these pages, let's create another folder and call it rooms. Inside this rooms folder, let's now create a file and call it room.ts. Now in the room.ts, now let's create a function and let's call this function find rooms. Okay, and that this function is going to return the type of iHouse, and let's see what is going to happen. Now we are going to get an error. TS compiler cannot actually find this interface in this particular file. So with the help of module, one thing we can do is to actually put an export. So in the front of this interface, we can actually export this, and now here we can import this iHouse. So you do that by simply using the imports keyword, and now we can import this from, just put dot here and put slash. Now you need to understand the folder structure. So putting dot here, so we need to move outside this folder. Remember, the room is inside the pages folder, and now we need to use dot and then slash. So now we have the rooms. We now have to add another dot and then slash. So now we have access to house. So from that house, we want to import the iHouse. Okay, so now you see that the error we have now is that this function must return this iHouse type. So here, let's simply say return. Okay, now we have access to this interface from a different file. We can also export this function simply by putting export here, and we can now go to any other file. So for instance, in the example.ts, we can actually import that. So here we simply say import, so dot slash, we are going to pages slash rooms slash this. So we are importing from the file inside the rooms folder, and the rooms folder is inside the pages. So now we can specify what exactly we want to import, and we are importing this find all rooms. So here we can simply write find all rooms. And now in this page, we can simply use this function to do anything we want. So basically, this is how you can import and export anything from your TS file. Now let's look at something else. In a very large code base, look at what we did here. In order to import, we had to go into pages, go into rooms. Now, assuming there is another folder and there is another folder, we have to keep going. So TypeScript also makes this very easy for us. What we can also do is to go back to our tsconfig file, include two things here. First, let's include the base URL because we want to specify the path. So here, let's say src. And next, we need to specify what we call the path. So here, let's include the path. And for this, we are going to write path. So here it is the rooms slash everything, and let's pass an array. And in this case, we want to specify the pages slash rooms and then slash everything. Okay, so now let's go back to our example.ts. Now, instead of writing all this, what we can easily do once we write import from, so we are importing from, now we can actually see this option at rooms. Simply click at rooms, then you specify your room, and that is all you have to do. Every other thing works very well. So even when the file is nested and nested and nested, we can actually use this tsconfig option to actually make our life very easy as a TypeScript developer. All right, I hope you enjoyed this course. Do not forget to like this video, subscribe, share, and also ask your question in the comment section below. See you in the next advanced course on TypeScript, and I wish you good luck. Bye.